Hi guys, welcome to my channel. In this video we are going to analyze a question, and we are going to analyze this question due to moment distribution method. And you can see there's a sideway in this question. So let's try to solve the question. The first I'm going to start with determining the stiffness factors. Stiffness factors BA is equal to 3EI over 20. Okay, it can stay like that. And for KBC, 4EI over 24, and for KCD is equal to 3EI over 20, and distribution factor for BA, 3EI over 20 over 3EI over 20 plus 4EI over 24 equal to 0.4737. Okay, distribution factor I don't need to do for all because you know how to do it. Yeah, now I showed here. So that will be 0.5263, and distribution factor for CB 0.5263, and distribution factor for CD equal to 0.4737. Yeah. Now let's write the distribution factors on the table, and then specify the fixed end moment. Then we're going to solve the question. For now, you can see there's a pin connection. Okay, so if it's a pin connection, this is 1 and this is 1. Okay, and this is going to be 0.4737. One second, I'm going to write. Sorry. .4737. Okay, this is going to be 0.5263. 0.5263. This is 0.4737. Now I have my distribution factor, so let's calculate the fixed end moments. Fixed end moment from B to C, that will be WL square over 12, so 1.5 times 24 square over 12. That will be equal to minus 72 gives feet. So fixed end moment from C to B will be equal to 72 gives to feet. And let's write the fixed end moment. This is 0, this is 0. And from BC, that is minus 72, and this is 72. This is also 0, this is 0. Okay, so now I have my fixed end moments. Let's try to distribute them. How I'm going to distribute? I guess you remember minus 72 times, for example, for this one, for BA, minus 72 times its own, distribution factor, 0.4737, okay, times minus 1. So that will be equal to 34.11, okay? So I'm going to write here 34.11. And this is also here, that will be 34 minus what? Minus 34.11, because 72 times this, it's the same, times minus 1. I'm going to get the same result, but the negative of that. For this one, that will be minus 72 times 0.5263, and times minus 1, that will be equal to 37.89. 37.89. That will be minus 37.89, okay, because it is the same, but it's going to be negative of that. So I can't make any carry over here because it can't be. This is going to be closed actually. until the down. This is going to be closed because I use the modified formula. So now let's take them here, the carryovers. The half of this one will come here. It will be minus 18.95. Okay, this will be 18.95. And I'm going to take this one, multiply with BA distribution factor. I'm going to write the negative of that here. So that will be minus 18.95 times 0.4737 times minus 1, that will be 8.98. Okay, and this is also will be 9.97. This will be minus 9.97. This times its own distribution factor and times minus 1 and right here. And this is also be minus 8.97. When I can't do it here, nothing will be, it will come here also. So I'm going to distribute this here, this both. This is going to be minus 4.98. When I carry over it, 0.5. I'm going to multiply with 0.5 and take half of this here. 0.5 and is also half of this here, 4.98. Okay. When I multiply with its own distribution factor, I'm going to obtain, and of course negative, because this negative, this will be positive, 2.62. This is going to be also 2.36, and this will be minus 2.62. This will be 36, and I'm going to, of course, make the carryover here 1.31. This is minus 1.31. Okay. When I distribute to this both, that will be distributed to its own, distribution factor, and I will obtain 0.62, 0.69. Okay, and this will be minus 0.69 minus 0.62. And actually, I'm going to write a little faster because the video will be longer. When I make the carryover here, minus 0.35, 0.35, and when I distribute to this 0.35, that will be 0.16, 0.18, or minus 0.18, 0.16. Okay. Let's finish this, and this is going to be minus 0.9, 0.09, sorry, 0.09. This come here, this come here, and this will be equal to 0.04, this will be 0.05, and this will be minus 0.05, minus 0.04, okay? And I'm going to distribute to each other from here. Minus 0.02, this come here, this come here. This is going to be 0.02, and when I distribute, it will be 0.01, 0.01, and because it's approximately, yeah, okay, 0.01, and minus 0.01, of course. And the result of moments, I will the sum of them, make them sum, and take the summation of them from this until the last row, okay? And here, this moment will be 46.28 minus 46.28 and 46.28 and minus 46.28, okay? For the first one, we solve the sideway questions. We are going to assume something like that. I'm going to draw here. We are going to assume, we are going to assume that it is supported, okay? Here like this. For example, this is our frame, okay? Normally we have a force here, okay? We are going to assume that this is supported here, of course. There is no sideway. First when we do it, first table, it will be assumed as there is a support here, so there is no any sideway, okay, and this is the force. And for the calculating of this shears, you know that this shears is equal to this is 15, okay, 15, this is AX, this is DX, okay, this is DX, so 15 plus, sorry, I guess there's a problem with minus R, minus AX, and minus DX. That's correct, equal to 0. So now in this question, we have as something like that. We have this both. I'm going to find this AX first. For AX is equal to this both moments, okay, this both moments over, think about this one. I have from A to B, I have from BA, this is B, okay, this is B, what is moment? At this direction, 48.20, okay? And when I find this one, I will write this. I'm going to take minus 46.28, because this is the negative for me. I take the counterclockwise direction as positive, over the length of this column. What is the length of this column? 20. And this AX will be equal to 2.340, okay? And for DX, this is also for DX. This for DX, that will be, what is for DX? CD. This is C, this is D. The moment at this direction. Okay, this moment at the moment at this direction. So 46.28 over 20 is equal to 2.314. This is negative, because you can see this is negative. So that will be something like this. 15 minus R and minus 2.314 plus 2.314. What is my R? R is equal to 15, okay? Now I find the first 15. Then I'm going to find the R prime, and I'm going to ratio of them. So I'm going to do it at the next part. And now it's okay. Now we say that this have a support. Yeah, this have a support. So there is no any sideway. First we just assume like that. Now we are gonna say that there is a sideway. So let's calculate it. The shape will be normally when it is side, when it is deflect. The shape will be something like this, I guess. Yeah? The shape will deflect something like this. There is a delta, and there is a delta here also, and this is at this direction will be rotate. Okay, so this will be minus. Okay, minus. So I'm going to give as minus 100 assumed. Okay, just I'm going to assume, and I'm going to find a ratio. Okay, I'm going to solve with this fixed moments, and I'm going to find the shears. From that ratio, I'm going to obtain the real moment value. So now the distribution factor will be also the same. There will be no change. So 0.4737, 0.5263, 0.5263, 0.4737. Okay. So now let's distribute it. That will be minus 100. When I distribute to this both, that will be 47.37. When I multiply with this and negative of that, multiply with this, and then I take the negative of this to right here, that will be 52.63, and also this will be 52.63, and this will be 47.37, This is 0, so this is 0, this is also 0. Yeah, this is 0, 0. And this is going to go on as, because it's going to use the modified formula to use distribution factors. Okay, so now I'm going to just make this carryover between these two moments. So let's do it. That will be 26.32, 26.32. And when I distribute at this ratios, okay, to here, take the negative of that also, 12.47, and this will be minus 13.85, and this will be minus 13.85. This will be minus 12.47. I'm going to distribute this both here. Sorry, carry over them, sorry. Minus 6.93, minus 6.93. I'm going to do this part a little fast, okay? $3.64, and this will be 3.64. This will be 3.28. I'm going to distribute this force at these ratios to BA and BC. Okay, so I'm going to take the carryover of this both, and this will be 1.82, so 82. And when I carry over them, there will be minus 0.86, minus 0.96, minus 0.96, minus 0.86. And this will be carry over this both, 0.48, 0.48, minus. So I'm going to distribute it this at its own distribution factor ratio, 0.23, 0.25, 0.23, 0.25, and that will be carry over this both. Oh, sorry. Yeah, this will be 0.25, this is 0.23. And for the next carryover, 0.13, 0.13, and this will be minus 0.06, minus 0.07, minus 0.07, minus 0.06, minus 0.03, minus 0.03, and this will be and this will be 0.02 and 0.02 and 0.02, 0.02. When I take the summation of the moments from the fixed moments until the last row, it will be minus 62.5, 62.5, 62.5, and minus 62.5. Okay. So now I have my moments. So let's find the previous thing I did, and I'm going to do it again. For here, this is A and this is B. I have BA moment. What is BA moment at this direction? Okay, I have AX, and this is 62.5, and AX is equal to 62.5 over 20. Okay, this is 3.125. And let's do it for the dx. This is dx, and this is also, I have a moment CD at this direction, 62.5. Okay, so dx is also equal to 62.5 over 20 is equal to 3.125. What is r prime? R prime is this one. R prime is this one. For example, this is 15. Okay, this is 15. This is 15. R prime will be like that. This is 3.25, 3.25, and this is R prime. R prime is equal to 6.25. Okay, when I subtract from 15 these two AX and DX shears, so I will obtain R prime. R prime is this. Now I need a ratio. Ratio is that R over R prime. Okay, this is equal to C. What is R? The first R is 15, the other R is 6.25, and equal to C as a ratio. I can use it like that, and I can find the result of that and use it. It's both, you can do it. So now let's find the moments. For moment BA, the first moments, the first table that I calculated for the 6.28, okay, plus that ratio 15 over 6.25 times minus 62.5 equal to minus 100 K feet. For moment BC, that will be equal to minus 46.28. This is the first moment I find, okay? Sorry, first moment I found it. Yeah, plus 15 over 6.25 times 62.5 is equal to 104 cubes feet, okay? For the moment also, CB, 46.28 plus 15 over 6.25 times 62.5 is equal to 196 cubes feet. And for the moment CD is equal to minus 46.28 plus 15 over 6.25 times minus 62.5 is equal to minus 196 cubes feet. Now we solve the question. Actually, if you did this right distribution and carryovers, of course you are going to obtain the right value. Don't forget to find R and R prime ratios, okay? You are going to obtain them from the shears. Now you can see from this shear, okay, you are going to obtain from this shear. And the question is that